right, so quiz tomorrow is on 9.5. So this is our 9.5 quiz prep for the quiz review. So for number 3, we want to match the polar coordinates with a point on the graph. And then we want to convert to rectangular coordinates. So first, starting with our degree. So we want to find 5 pi over 4 on our graph here. So 5 pi over 4 would be here. And then our point, our r, is -1. If your r is negative, do we go towards the degree or away from the degree? We would go away. We go in the opposite direction. So we go away from 5 pi over 4. So that would put us at a point right here. So we go 1 unit away from 5 pi over 4. So remember, if r is positive, we go towards theta. If r is negative, we go away from theta. Any questions here? Awesome. Let's convert it to rectangular. So given our polar, when we convert to rectangular, we have x is equal to r times what? Cosine or sine? Cosine theta, perfect. And y is equal to r times sine of theta. So these formulas you have to know for the quiz tomorrow. So x is equal to r, which is -1, times cosine of 5 pi over 4. We want to use our unit circle to figure out what the cosine of 5 pi over 4 is. So that would be down here. Cosine tells us we look at the x or the y. We're going to look at the x, so our x would be negative square root 2 over 2. So x is equal to -1 times negative square root 2 over 2, which would be positive square root 2 over 2. So that's our x value. To find our y value, we're going to do the same thing. We have y equals -1 times sine of theta, which our theta is 5 pi over 4. Sine, we look at the y value, which is negative square root 2 over 2. So y equals -1 times negative square root 2 over 2, which would give us positive square root 2 over 2. So our y would be positive square root 2 over 2. So this would be our rectangular coordinate. If we were to graph our rectangular coordinate, we'd go to the right, square root 2 over 2, and up square root 2 over 2. So it'd put us here, which would match where we put the polar coordinate. So it'll always correspond to each other. So we're going to plot the point given the polar coordinates and then convert. Actually, this one we're finding 3 additional polar representations of the point. So let's plot our point first. We're going to go to 2 pi over 3. 2 pi over 3 would be here. And our r is positive, so we're going to go towards 2 pi over 3, 2. So I'm going to go out 2 rings, 1, 2. So our point would be there. Now to find 3 additional points, if we keep 2 the same, so if we keep the sign of 2 the same, what would I add and subtract to 2 pi over 3? 2 pi, we would add 2 pi and subtract 2 pi, perfect. So I'm going to add 2 pi first. We need a common denominator, so I can make it 2 pi over 1, multiply the top and the bottom by 3, so this ends up being 6 pi over 3. So here our point would be 2, 8 pi over 3. Is 8 pi over 3 in between negative 2 pi and positive 2 pi? How many times does 3 go into 8? 2 with more left over. 2 with 2 left over. So it's more than 2 pi. So this is not in our interval that it gave us here. It's not in between negative 2 pi and positive 2 pi. So let's try again. So we're going to keep 2 the same. Now we can subtract 2 pi. So I'm going to take 2 pi over 3 and subtract 2 pi, which is 6 pi over 3, just to give it a common denominator. So now we get 2 comma, this would be negative 4 pi over 3. Is negative 4 pi over 3 in between negative 2 pi and positive 2 pi? Yes. So that works as one of our points. For our other 2 points, we need to switch 2 to be negative. So I'm going to call it negative 2. What do I add and subtract when I switch 2 to be negative? Pi. Awesome. I'm going to add and subtract pi. So I take 2 pi over 3, and I'm going to add 3 pi over 3, because that's pi. So when we add here, we get negative 2 comma, our new point would be 5 pi over 3. Is 5 pi over 3 in between negative 2 pi and positive 2 pi? Yes. Then I'm going to switch to negative 2, so now we can subtract pi. So we want to add and subtract pi. So we have 2 pi over 3 minus 3 pi over 3. So our new point would be negative 2 comma negative pi over 3. Is negative pi over 3 in between negative 2 pi and positive 2 pi? Yes. So these would be our 3 additional points. So you're not able to just keep adding 2 pi. You can't just call it 2 comma and keep adding 2 pi as many times as you want, because it gives us that restriction in between negative 2 pi and positive 2 pi. Our theta can't be more than 2 pi. So we can't just keep adding 2 pi. So we have to change the sign, and when we change the sign, we just add and subtract pi. So if we keep r the same, we would add or subtract 2 pi. If we change the sign of r, then we would add or subtract pi. But just make sure that your theta is in between negative 2 pi and positive 2 pi.
How do we know if it's in between negative 2 pi and 2 pi?
You have to look at the numbers. So here, for the first one that we said it's not in between, we had 8 pi over 3, or 8 over 3. Well, think about the decimal version of this. If I divided 8 by 3, it would go in twice with more. So it would be 2 point something, which is outside of 2. So it'd be more than 2. So just kind of ignoring the pi's, you just want to see, is it in between negative 2 and positive 2? Yes?
On the quiz, you're gonna make us put it from small to large?
No, just on the quiz it'll just say to name the 3. You wouldn't have to list them in order. Just find 3 that are in between negative 2 and positive 2. For the next question, we want to plot the point and convert to rectangular. So let's find out where negative 7 pi over 6 is. We could either count to where 7 pi over 6 is and then just go in the negative direction, that many, or we could just convert this to the positive coterminal angle. Either way works. So if we wanted to count, we would go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we go around the circle 14 in the positive direction to get to 17 pi over 6. So to get to negative 17 pi over 6, we would need to go 14 in the negative direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it would be this one here. Or another way that we could find that is we could keep negative 1 and then just add 2 pi to it. So we'd want to find a positive coterminal angle. We could add 2 pi. So we'd add 12 pi over 6, which would give us 5 pi over 6. So you could either count or just add 2 pi to it to make it positive. So I found 5 pi over 6. Since it's a negative r, are we going towards 5 pi over 6 or away from 5 pi over 6? We're going away from 5 pi over 6. So instead of going towards the direction of 5 pi over 6, I'm going to go in the opposite direction, 1. So my point would be there. Now we can convert it to rectangular. If you want to keep the negative 7 pi over 6, you can, but negative 7 pi over 6 is not going to be on the unit circle. So my suggestion is to keep the positive coterminal angle of it. When you're using the unit circle, you want your theta to be positive. So we're going to use this one to convert it. So when we convert it to polar, we have x equals r times what? Cosine of theta, and y equals r times sine of theta. So x is equal to negative 1 times cosine of 5 pi over 6, and y is equal to negative 1 times sine of pi over 6. So I'm going to go on my unit circle, find where pi over 6 is. That would be here. So cosine tells us we look at the x or the y? We look at the x, so our x would be negative square root 3 over 2. So we have negative 1 times negative square root 3 over 2, which would be positive square root 3 over 2. Then our y is the sine, so we're looking for the sine. Sine tells us we look at x or the y? The y. So y would be 1/2. So we have negative 1 times 1/2. So our y would be negative 1/2. So our coordinate here would be square root 3 over 2, comma, negative 1/2. Yes?
Where did you get pi over 6 from?
When we found the positive coterminal angle of it, we added 2 pi to the angle.
Okay.
That's where we got the 5 pi over 6, because negative 7 pi over 6 is not on the unit circle.
Now where'd you get pi over 6 by the sign?
This should be 5. Sorry. If we were to just plot our xy coordinate, or rectangular coordinate, we would go to the right, square root 3 over 2, and down to negative 1/2. So it would put us in the 4th quadrant there, which is where our point is on our graph. So you can always kind of check your work that way. See if you plotted it in the right spot. If you found the correct x and y, your point's going to end up in the same place. For 6, we want to plot the given point in the rectangular coordinates, and then find 2 sets of polar coordinates. So first we can plot our point. So we're going to stay at 0, go down to negative 8, so that would put our point here. So we've got this graph. Even if the question on the quiz does not ask you to graph your rectangular point, I would always suggest graphing it. That way it'll help you find your theta in our polar point. So next we want to convert it to polar. So I am going to write my polar. We have r squared is equal to x squared plus y squared. And then tangent of theta is equal to y over x. So r squared is equal to 0 squared plus negative 8 squared. So r squared would be 0 plus 64, which would just be 64. Take the square root, r is 8. Now remember, we said that this could be plus or minus, but we're just going to keep the plus. Now let's find our theta. Tangent of theta is equal to negative 8 over 0. This gives us undefined. So So we can't really simplify this, but let's see where on our unit circle would we get undefined for theta. And keep in mind, our point is on the y-axis down at the bottom. So that's really going to tell us where we need to look. What theta would I be looking at here? What theta would give me y over x is undefined? 3 pi over 2. Perfect. Which ends up being in the same spot that we plotted our point. So it's always going to work out that way. So our theta is 3 pi over 2. So our point would be 8 comma 3 pi over 2. It's always r comma theta. Let's do the same thing for 7. Let's plot our point first. We're going to go to the left to -3 and down -3. So that would be our point here. So we're looking at the first graph. Next, we want to convert it. So we have r squared equals x squared plus y squared. And tangent of theta is equal to y over x. So r squared is equal to -3 squared plus -3 squared. So r squared is equal to 9 plus 9. R squared is 18. Take the square root. So r would equal, let's simplify our square root. What are 2 factors of 18? 9 and 2, and 9 would be 3 and 3. So r would equal 3 square root 2. Now let's find our theta. So tangent of theta equals -3 over -3, which would simplify to 1. So we want to find where on our unit circle would we get 1 when we do y over x. Looking at our graph of our rectangular point that we already plotted, it's in the 3rd quadrant, so that's where we need to look on our unit circle. So on our unit circle in the 3rd quadrant, which point would give us y over x is 1? 5 pi over 4, perfect. If you want to just check real quick, if we did negative square root 2 over 2 over negative square root 2 over 2, this would simplify to 1. Perfect. So 5 pi over 4. So our point would be 3 square root 2 comma 5 pi over 4. All right, looking at number 8, we want to plot the given point and then convert it to polar. So same thing we did in the last one. For here, we don't really know exactly how big 2 square root 3 is or how far we're going to go to the right. We just know that we're going to the right. It doesn't matter how far we go to the right. We just know that it's positive, so we go to the right, and then y is -2, so we would go down. So we're looking at the first graph here. So let's convert our formulas. Our r squared is equal to x squared plus y squared, and tangent of theta is equal to y over x. So r squared is equal to 2 square root 3 squared plus -2 squared. What is 2 square root 3 squared? Remember, we have to square the 2 and square the square root 3. So what's 2 squared? 4. And what's square root 3 squared? 3. So we have 4 times 3, which would be 12. Plus, what's -2 squared? 4. So r squared equals 16. So r would be 4. Perfect. So we have our r. Let's find our theta. So tangent of theta is equal to y. So -2 over 2 square root 3. This would simplify to -1 over square root 3. Now we want to find where on our unit circle does y over x simplify to negative 1 over square root 3. You could rationalize this if you want, but when you simplify in your unit circle, you'd want to rationalize. So you don't really have to. If you don't rationalize here, don't rationalize when you find your theta either. We're just looking for the theta, so it's not like this is our final answer. So we are looking in which quadrant? The fourth quadrant. Perfect. So I want to see, where do I get a y over x equal negative 1 over square root 3? So in my fourth quadrant, it's either going to be 11 pi over 6 or 5 pi over 3. Let's try them both. So for 11 pi over 6, we would get negative 1/2 over square root 3 over 2. If I have a fraction in a fraction, what do? Keep, change, flip. Keep the top, change to multiplication, flip the bottom to 2 over square root 3. This would simplify to negative 1 over square root 3. Is that what we're looking for? Yeah. So it would be 11 pi over 6. So we knew that it was either going to be 11 pi over 6 or 5 pi over 3 because those were the only ones that had a square root 3 in it. If you're not sure, just do y over x and see which one simplifies to what you need. So we were lucky and got it on the first try. 11 pi over 6 would be our theta. So our point would be 4, 11 pi over 6.